Mathematicians, are you ready for a challenge? Today you will learn how to classify triangles based on the lengths of their sides and the measures of their angles. No protractors today, though, just the knowledge of acute, obtuse, and right. Okay, so I want you to look at the three triangles on the screen. How are they different from one another? Just concentrate on their angles. How are the triangles different from one another? Pause the video and think. I hope you noticed that the left orange triangle has one right angle. That is called a right triangle. The bottom green triangle has three acute angles. That is called an acute triangle. The one on the top, the purple, is an obtuse triangle because it has one obtuse angle. Okay, now I want you to concentrate and look only at the triangle's sides. Forget about the angles for a second and only look at their side lengths. What do you notice is different about the three triangles and their side lengths? Thank you for looking at those triangles. If you still haven't, go back and look at them yourself. But the red one is called an equilateral triangle. And to be quite honest, on a geoboard, those side lengths aren't exactly the same, but they're supposed to be. It's impossible to make an equilateral triangle on a geoboard, so we're pretending. The isosceles triangle has two sides exactly the same length. Can you see them? And then one is different. And then the scalene triangle, all three side lengths are different. You are about to embark on one of my favorite activities. Are you ready? Are you going to persevere? To do this activity, you either need to search for a geoboard on your computer by searching Math Learning Center geoboard, or just get out a piece of paper and a ruler and a pencil, or a tape measure if you can find one around your house. If you know the voice behind this video, Mrs. Moon, you know that she, me, loves mathematics, and I love a good challenge. So this next activity is something that you are really going to have to think about. Now that you know to name triangles by their sides or by their angles, you can name them by both of those things. So you are going to try to make 9 different triangles. You're going to make a scalene acute, a scalene right, a scalene obtuse, and in each of those boxes, make that chart on your paper and draw them in. Now, I'm not going to lie, this is such a hard challenge that after about 10 minutes of trying, it's okay to stop. The reason I say it's okay to stop is because there are some mysteries behind this puzzle. Some of the boxes might be hard to fill in. So do your best, persevere, have endurance as you try to figure out each of the boxes, but know that some of the boxes might be hard to fill in. Hopefully you have persevered and filled out the chart, or at least most of it, because here comes the answer key. Now, I hope you're not surprised, or I hope you figured out why I said there were some mysteries. That's because, are you ready? Drum roll, please. I hope you tried. 2 of the boxes on the chart are impossible to fill. Look at my pictures and see if they are similar to some of yours. You can pause if you need to, or you can keep listening. Why is it that an equilateral right triangle isn't possible? Why is it that an obtuse equilateral triangle isn't possible? What do you notice about my pictures? Hopefully, those stumped you. I didn't want to cause you overwhelming stress, but I did want you to kind of think about, could you make one of those? You'll notice how the other 7 were possible. I do want you to notice a couple more things because you're going to be looking at triangles in a minute and telling what they are in both the angle vocabulary and the side vocabulary. So across the top, you've got acute triangles. They've got to have all 3 acute angles. Right triangles only have 1 right angle, and obtuse triangles only have 1 obtuse angle. Then you've got scalene triangles that have no sides the same. And do you see the tick marks? When they put 1 little tick mark, 2 little tick marks, and 3 little tick marks on the sides, it's showing that they're all different. But look down at the isosceles. When they put the same tick mark on 2 of the sides, they're showing they're the same. And then on the equilateral, when they put the tick marks on each side of the equilateral, they're showing that all 3 sides are the same. So the type of tick mark that is there is showing you which sides are equal to one another. The next slides that come up are going to come up kind of fast. You'll see a picture of a triangle. It'll give you about 10 seconds, no more, to think, name it with both names, and then it'll show you the answer really quick. So it'll be like a mystery game, but you're going to have to be fast. So every time a new picture shows up, it'll give you about 10 seconds, and that's it. I hope you got some of those triangles right. If you didn't, go back to the chart and try them again. Look at your chart as you're looking at each triangle and see if you can identify by sides, isosceles, scalene, equilateral, and by angles, acute, obtuse, and right. With all that you've tried today, learning about angles and sides of a triangle, look at each box and identify What is the same about all five of the triangles in each box? You only have to name it with one name. So, like, what do all five of those first box triangles have in common? And then look at the second box. And then look at the third box. What do you think? The first box didn't stump me. I saw that they were all acute. But the second box got me. Did it get some of you? I thought it was obtuse at first, but then I saw some that were right and some that were acute. And that's when I realized they were isosceles. They had two sides the same. And then the last box, I could tell they all had at least one right angle. I hope you enjoyed today's lesson. If you would like to stay tuned for a bonus clip that's pretty amazing, you can. Otherwise, don't forget to do some of your exit ticket work today, and I hope you enjoyed today's lesson. Hello, boys and girls. Did you stay on the video just so you could see the bonus clip? I'm sure you did. If you want to participate in this experiment along with me, get a piece of paper and make a triangle and cut it out. And if you will, make sure it's a big enough triangle so that when you tear off the three vertices, you won't make the triangle disappear. So make a pretty big triangle, cut it out, put 3 dots on the corners. Pause the video right now if you might need time to do that so you don't get it spoiled. Okay, tear off the 3 corners. So notice I'm tear off all 3 vertices. That's the correct term. They're vertexes, so vertices is the plural. So I'm cutting off all 3. And would you agree that all of our triangles are probably different? Like, you didn't make the one just like mine, and your friend didn't make the one just like mine. Everybody probably made a different triangle. Okay, so once you get your triangle, we are going to take the 3 vertices, and you guys can notice all 3 of my vertices are acute. Do you notice that? That just randomly happened. You could make a triangle that has an obtuse angle, okay? When you get all 3 vertices cut off, I want you to line them up by their points or by their vertices. So do you see how I'm lining them up? Oh my gosh. Come on, tell me you see what just happened. 4th graders or anyone watching, what happened when I put all 3 of the vertices, the vertices together? I won't say it. Don't spoil it. I won't spoil it. You're right. They made a straight angle. Every single triangle, no matter what, if it's really a triangle, every single triangle has vertices that add up to 180 degrees. 180 degrees. I hope you enjoyed that bonus clip. I wish I would have said it a little bit differently, but couldn't redo that fabulous video. It's the angles. I cut off the vertex, the point, the angles, but it's the angles of the triangle that come together. The angle measures and make 180 degrees. I suppose it's also the vertices, but I really wanted to say it's the angle measures that add up to 180 degrees, no matter what. I showed you 3 extra pictures. You could try it on tons of triangles. It will always work. Have an awesome day.